A Short History of the Mind and Some of the Weird Things We've Thought About It. Information and Complexity, Essay 2. What is the mind? If you've ever thought about this question, you've probably run into René Descartes. He's the guy who famously argued that the mind and the body are made of completely different stuff, one physical, one immaterial. His ideas shaped the conversation for generations. But of course, the story doesn't end with Descartes. Ideas about the mind aren't set in stone. They shift with the times, like intellectual fashion trends. What we think the mind is influenced by what's happening in philosophy, science, and even technology. Today, if you tune into a podcast or pick up a popular book on the mind, you won't hear much about what the mind is made of. Instead, the focus is on what it does: thinking, deciding, remembering, feeling. It's about function, and one of the key functions of the mind, it seems, is to process information. How did we get here? How did we go from philosophers arguing about evil demons tricking our senses to a world where the mind is framed in terms of information processing? To answer that, we need to take a little trip through history. Along the way, we'll meet some contemplative philosophers, some revolutionary psychologists, and a surprising theory borrowed from the world of codebreakers. Let's take our trip in 3 stages. 1, the move from philosophy to science. 2, the rise and fall of behaviorism. And 3, the sneaky influence of information theory. 1, the move from philosophy to science. If you ask someone today, who studies the mind? They'd probably point to a cognitive psychologist, maybe someone in a lab running experiments or scanning brains. But not long ago, the mind wasn't something you studied with machines and measurements. It was something you thought about. The mind was philosophers' territory. And one of the biggest questions these philosophers wrestled with was knowledge. How do we know what we know? And how can we be sure we know anything at all? On this question, philosophers split into 2 camps: the rationalists and the empiricists. Rationalists believed that reason was our most reliable tool for understanding the world. If you want to uncover truth, they argued, the best place to start is with your own thoughts, carefully working through ideas, step by step. Empiricists, on the other hand, weren't having any of that armchair speculation. For them, knowledge came from the senses. If you want to know how the world works, you have to get out there and observe it. Like most intellectual divides, the reality was messier than the labels suggest. Few thinkers were purely on one side or the other. Even Descartes, the poster child for rationalism, borrowed from both camps. His famous "I think, therefore I am" is a classic rationalist move. But elsewhere, he wrote about the importance of studying nature through observation. Still, during Descartes' time, rationalism was in fashion. But by the late 17th century, the tide was turning, especially in the English-speaking world. What changed? Science. While philosophers debated knowledge in the halls of academia, something seismic was happening in the world of science. Astronomers were charting the heavens with telescopes. Biologists were peering into the hidden world of cells with microscopes. And the scientific method, based on observation, measurement, and experimentation, was transforming how we understood the universe. With that shift came a new way of thinking about the mind. If the best way to understand the natural world was through observation and measurement, maybe the same was true for the mind itself. Enter John Locke, one of the first philosophers to really run with this idea. Locke argued that the mind starts out as a blank slate. Tabula rasa. Everything we know, he claimed, comes from experience. No built-in truths, no innate knowledge, just sensory impressions slowly building up over time. David Hume took this further. He wasn't just interested in what we know, He wanted to understand how thoughts stick together in our minds. He came up with the laws of association, a set of rules that explain why certain ideas seem to naturally follow others. If two things happen close together in time, we assume one caused the other. If two things look alike, we link them in our minds. Locke and Hume were still working with ideas, not experiments, but their influence planted a seed. If experience shapes the mind, and if thought follows predictable patterns, then maybe the mind could be studied in the same way as the natural world, systematically, scientifically, and even experimentally. Philosophers had laid the foundations, but the study of the mind was about to break free from philosophy. It was becoming a science. 2. The rise and fall of behaviorism. In the late 19th century, a new discipline began to emerge, one that aimed to study the mind not through speculation or introspection, but through careful observation and experiment. Psychology. At first, psychology's ambitions were broad. Early pioneers like William Wundt and William James explored everything from perception and memory to attention and emotion. They believed the mind could be studied scientifically, without abandoning the richness of inner experience. But by the early 20th century, psychology took a dramatic turn, and in some ways, it narrowed its focus. Enter John B. Watson. Watson wanted to turn psychology into a proper science, one that could rival physics or chemistry. But there was a problem. Thoughts, feelings, and mental states weren't observable. You couldn't see them, measure them, or put them under a microscope. And for Watson, that made them unscientific. If psychology wanted to be taken seriously, he argued, it had to ditch the whole messy business of the mind altogether. Instead, psychologists should focus only on what they could observe directly: behavior. And just like that, behaviorism was the new trend. The behaviorists took Locke's blank slate idea as a starting point. If the mind begins empty and all knowledge comes from experience, then psychology should focus on how experiences shape behavior. In other words, they should focus on learning. And if Hume's laws of association explained how ideas stick together, maybe Hume's laws could explain how we learn everything, from walking to language to complex problem solving. Watson's idea was not new. Philosophers had been arguing about it for centuries. But now behaviorists wanted to take it a step further. If learning was just a matter of experience and association, could psychology predict and control learning? This was the era of the famous conditioning experiments: Pavlov's dogs salivating at the sound of a bell, B.F. Skinner's pigeons pecking at levers for food. Even Watson himself made a bold claim. Give him an infant, and with the right conditioning, he could turn them into a doctor, a lawyer, or even a tightrope walker. Behaviorism was an idea that fit neatly with the American dream. If everyone starts with the same blank slate, then success isn't about talent or innate ability, it's about learning. Given the right opportunity and hard work, every person can succeed and attain a better life. By the mid-20th century, behaviorism was psychology. Nearly every major department in the US was run by behaviorists. The study of the mind, once the realm of philosophers, had been stripped down to stimulus and response. But not everyone was convinced. What's surprising isn't that behaviorism rose to dominance. It's how long it managed to hold on, despite mounting evidence that something was missing. Philosophers like Descartes had argued centuries earlier that the mind must have innate structures that shape how we think. Kant suggested that certain ways of understanding the world, like space, time, and causality, might be hardwired into our brains. Even Darwin's theory of evolution hinted that mental capabilities, just like physical traits, could be products of natural selection. Yet behaviorism pushed all of that aside. The idea that learning was everything became dogma. For decades, psychology largely ignored the role of biology in shaping the mind. But outside the US, the first cracks in behaviorism's hold were starting to appear. In Montreal, Donald Hebb proposed what, at the time, seemed like a radical idea. Learning wasn't just about external behaviour. It had a biological basis. His theory is now summed up by the phrase, "cells that fire together wire together," suggesting that learning happened through changes in the brain's wiring. But in the US, the challenge to behaviorism didn't come from biology. It came from a completely different way of thinking. It redefined what the mind is. This new way of thinking wasn't about behaviour. It wasn't even about biology. It was about information. 3. The sneaky influence of information theory. Right now, if you were to name the most influential figures in psychology, you'd probably rattle off big names like James, Pavlov, Skinner, Piaget. But one of the most quietly influential figures in how we think about the mind today isn't someone most people recognise. His name was George Miller, and in 1956, everything he thought he believed about the mind was about to be turned upside down. In the early 1950s, Miller was like most American psychologists of his time, a committed behaviourist. He was interested in language and communication, and unsurprisingly, he believed their foundations were rooted in stimulus, response, and reinforcement. But then came 1956. Miller attended a symposium, and everything changed. Before we get to that moment, the moment Miller's entire perspective changed, let's zoom out for a second. Because something big was brewing outside of psychology. Something that had nothing to do with rats in mazes or conditioned responses. Something that wasn't supposed to be about the mind at all. The hot topic was information. Just a few years earlier, Claude Shannon had published a mathematical theory of communication, and the new field, information theory, was causing a stir. Shannon wasn't a psychologist. He wasn't trying to crack the mystery of the human mind. He was a mathematician who wanted to figure out how to send messages more efficiently. But in doing so, he accidentally gave us a whole new way to think about thinking, though not exactly in the way he intended. Shannon's information theory at its core is about quantifying information. Information was defined as the reduction in uncertainty when we learn the outcome of an event. Let's say our event is turning over the top card in a deck of playing cards. Take an unshuffled deck so you know the order of the cards. When you turn over the top card, do you gain any information? No, you don't gain any information because you know the order of the cards before you flip over the top card. You know exactly what the top card will be. There is no uncertainty, no surprise, no learning, no information. But what if the deck was shuffled? With a well-shuffled deck, you don't know what the top card will be. When you flip over that top card, your uncertainty drops. You learn something new. That, according to Shannon's theory, is information. If you want a deeper dive into Shannon's information theory, I wrote a more detailed explanation in my essay, What is Information? But let's get back to 1956. In September of 1956, at MIT's second symposium on information theory, our friend George Miller sat in the audience. Miller listened as engineers, mathematicians, and computer scientists described how machines could store memories, solve problems, and process information. And something clicked. If computers do this, couldn't the mind? Maybe learning wasn't just stimulus, response, and reinforcement like behaviorists claimed. Maybe the mind was processing information. That was the moment behaviorism lost its grip on Miller. Back in 1951, Miller had written a book called Language and Communication. And right there in the preface, he made his stance clear. The bias is behavioristic. At the time, that wasn't surprising. Behaviorism was psychology's dominant framework, especially in the US. But fast forward 11 years, and Miller's writing had a very different message. His new book was called Psychology, the Science of Mental Life. The title alone said it all. This wasn't just a slight shift in perspective. This was a complete break from the idea that psychology should only study behavior. With that book, Miller wasn't just changing his own mind, he was helping to change the entire field of psychology. The cognitive revolution was in full swing. Psychology had moved on from behaviorism. Psychologists weren't the only ones breaking away from behaviorism. Philosophy was going through its own transformation. In 1963, Hilary Putnam introduced a now famous thought experiment that exposed a major flaw in behaviorism. Imagine a society of super Spartans, people who feel pain but never show it. No grimacing, no wincing, and no crying out. If you saw them, you'd never know they were in pain. As we know, behaviorists thought pain was just a pattern of behaviour, grimacing, wincing, and crying out. But Putnam's thought experiment made that idea look absurd. If pain were only behaviour, then these super Spartans wouldn't actually be in pain. But according to the thought experiment, they were in pain. Putnam argued that this meant pain had to be more than just behaviour. Putnam was making a case for functionalism, the idea that mental states are defined by what they do, not by what they are made of. Just as psychology was shifting from behaviorism to cognitivism, philosophy was shifting from behaviorism to functionalism. These shifts weren't identical, but they share a crucial commonality. Both abandoned the idea that mental states could be fully explained in terms of external behaviour. Cognitivism embraced information processing directly, while functionalism set up a framework that would later click perfectly with computational models of the mind. In their own ways, both cognitivism and functionalism were stepping stones to an era in which thinking about the mind meant thinking about information. Nowadays, it's common to think of the mind as an information processor. Before this shift in thinking, mental processes, things like memory, problem solving, even consciousness, were seen as off limits to science. Too abstract, too mysterious, too unobservable. But thinking of the mind as an information processing system changed the rules. Suddenly, things that once seemed unknowable could be measured, modelled, and tested. The mind wasn't a blank box anymore. It was something you could study. But there's a catch. What we mean by information and information processing has expanded far beyond what Shannon originally meant, especially in psychology and philosophy. When we say computers process information, we mean they process something close to Shannon-style information. Signals, statistical patterns, bits that flow from one place to another. But when we talk about the mind processing information, we often mean something more. The information has meaning. Shannon's information theory was never about meaning. As he put it, the semantic aspects of communication are irrelevant to the engineering problem. He wasn't concerned with what a message meant, only with how efficiently it could be transmitted. But cognitive psychologists and philosophers, they care about meaning. When we say the brain processes information, most of us aren't thinking about that information as Shannon's bits and bytes. We're thinking about information as something that means something to the system, the system being us. When we talk about the brain storing information, aka memory, we don't just mean raw data. Memories for us have significance, interpretation, and meaning. Yet, despite these different concepts of information, we still draw parallels between the information processed by a mind and the information processed by a computer. But how different are these kinds of information really? Is information just one thing, or are we lumping together fundamentally distinct ideas under the same word? And if they are different, does the difference matter? If we imagine artificial general intelligence, AGI, we are potentially mixing together multiple meanings of information, blending Shannon-style information processing with other mathematical frameworks, as well as cognitive theories about meaning and representation. The boundaries between these definitions of information aren't always clear. And with this slippery concept of information precariously in hand, we like to ask questions like, if the mind is an information processor, why couldn't a machine that processes information have a mind? Next week. Earlier this year, just for fun, I wrote some code to analyze the words I use most frequently in my essays, excluding all the usual suspects like the is and and. The top two words, brain and consciousness, no surprises there. But the third most common word, information. We lean on the word information all the time, and not just when we talk about mind and computers. Weather forecasts, medical diagnoses, and even restaurant reviews rely on the careful interpretation of information. But do we even know what we mean by information? Next week, let's start pulling on that thread. From DNA to black holes, information seems to take on different meanings depending on the context. We have to start somewhere. So let's start by pulling on the physics thread. What happens when information theory meets physics?